Good afternoon, guys. How's it going?
Hey,
How you guys doing?
great, Kevin. How are you?
Hey,
Good, good. Let's have some fun with this conversation. Tim was really excited about this when he was playing with these tools before in this project, and so we're here to talk about this kind of stuff and let everybody know about how cool some of these ideas are. So the idea here, I'll start this off, and then what I'd like to do is to kind of continue the conversation here with Dave and with Tim, with you guys about various aspects of this specific solution that we've got here. We're looking at the screen of that solution. But I'll start it off by saying that our objective here is to talk about the value of some newer ideas, newer architectures, newer tools, like using MQTT data brokers. See, Tim, I already tripped over that name. It is hard to say. MQTT data brokers and unified namespace, using tools like HighByte and whatnot, and how these tools can really help a lot in solutions. And I think the place to start the conversation is around the layers that you typically have with an industrial company. A lot of manufacturers and other industrial companies, mining, et cetera, will have an ERP system. At the top, they'll have an MES system, manufacturing execution system. Below that, they'll have PLCs and HMIs. And actually, I think I have some of these, this organized a little bit differently than some, where I've got the SCADA on the same level as the PLC and HMI, and sensors at the edge. And when you have these different pieces of the technical puzzle for a company to operate, you'll sometimes have these systems talk with one another. An ERP might talk intermittently with an MES. Certainly, you're going to have a PLC and HMIs talk with your SCADA system, and the SCADA to the MES sometimes as well. But when you actually do those connections, most companies will create discrete connections between each of them. And there will be connections all over the place, ERP to the SCADA, ERP to the MES. Some PLCs might even be reporting directly to the ERP itself, depending on the company and what kind of legacy systems and legacy solutions they've created. And what you really end up with is just a big old mess of things. And if you want to swap out one of those systems, good luck. Hope you get the budget to be able to do that and rip and replace a lot of those connections. The idea, a better idea would be to fall in line with some of the ideas from ISA 95, where we are talking about the layers of an organization, like we've already represented, and looking at those as discrete, separate areas of an organization where to work, to operate, to store the data, et cetera. But then once you want to start to share data between those applications, it's better to use a central hub, a central place to actually store that data. And that central place would be a data broker, and also at the same time to be able to use a unified namespace. You want one single place to put this data, to organize it. And so in this situation, we'd use the unified namespace. And the unified namespace is really meant to give structure to this data across the organization. Why would you want to do that? Organized data is easier to find, and organized data is easier to find places where you can put the data into, to pull the data out of. And the structure that we would use is, again, something recommended by the ISA 95 standard, which is enterprise, site, area, line, and cell. And so what you would do with that data, if you want to have some data from your PLCs actually get into the MES system, you would create a specific connection between your PLC to this unified namespace, this hub, with a data broker tool, and publish that data into this hub, if you will. And then if that MES system needs some of that data, it knows exactly what to pull because the data has been organized in this structure, and then it will subscribe to and pull the data out into the MES. Same thing with an ERP sharing data with MES, same thing with any system sharing anything anywhere else. And then at that point, what you're able to do also is to even push the data to a cloud. And again, keep all the data really nicely structured. This then applies for a specific area of the plant. You can create a setup like this for an area of the plant, for a whole plant, or then for a whole corporate structure with multiple plants reporting to an enterprise level organization, headquarters or something like that. Dave and I have already done a number of videos on some of this stuff. Feel free to look at our YouTube channels for that information and for those videos, because they really help describe these concepts really well and how to implement some of the technical aspects of them. The idea here at a higher level is really to help a company go through a digital transformation, moving from that old Industry 3.0 way of thinking of discrete connections, et cetera, to Industry 4.0, open systems, open technologies, sharing data, and becoming ultimately, call it a data-driven manufacturing organization, or call it, that was another good phrase, a digital factory, where you have all of the systems, all of the machines, all of the people connected and networked, and everybody is connected to that network and using the data in that network to understand exactly what's going on with an organization. And all the stakeholders have a real-time perspective on the current status of the enterprise, as well as the future status of the enterprise. It's that full connectedness of data that helps an organization become really data-driven. And by following that data, then they can understand what's going on and make the valuable decisions, critical decisions they need to keep growing and expanding the business. And it comes down to architectures like this and ideas like this, the unified namespace, and having a way to organize that data across the whole organization, across all levels and all systems, and publishing that data to a central namespace and a central tool called a data broker, and being able to pull that data out, subscribe to it in any one of those other systems, that really enables this wide sharing of data, and then, of course, and supports the data-driven concept for companies. Dave, did I miss anything there? Any major points?
No. I think it's, if I understand what you're saying, is that rather than me connecting all of my devices in this one-to-one through the old way, I'm now bringing it all into this broker. So it becomes more of a producer of intelligence, if you will. It's more of a, this is the kind of data I'm producing, and then this is the kind of data I'm producing, or consuming rather.
Yes.
Oh, okay, cool.
Yeah, that makes complete sense. So we have implemented this system or this architecture and these ideas a number of times, and what we thought we'd do is to talk about one of those situations. Unfortunately, can't share the company name, but we can talk about it in principle at a high level. So what we're going to do is to talk about the current solution that they have, which is a little bit more like this, and then we'll get into what the whole solution looks like. So, Tim, do you want to talk about actually what's going on, what the kind of the situation overall for the company, generally at a very high level, what they do, and then the current solution and how it works, or I should say the old solution, how it works?
Yeah. So the old solution, it kind of is a mess like this, but I mean, you can imagine it's a solution that started 20 years ago and has made it to today. So it's gone through a lot, and ultimately it's a bunch of different data sources. These are access databases, XML files, CSV files, PLCs, let's see, SQL Server databases, and even data sources that are only available through proprietary web pages, where you have to scrape that data out off the screen. You actually get the HTML and extract the data, and it's done currently with 30 plus some odd individual custom written applications that interface each one of those different things. So an application to scrape HTML from system A, an application to scrape data from system B, an application to get data from one of the access databases, to get data from the PLC. Like all these individual little applications, custom code written from scratch to get this data, and then put them into their own little siloed access databases. And then on top of that, additional custom applications, custom code written to do specific things, to aggregate those access databases into another access database, and then even more applications on the top of that to take that aggregated data and push it out, to disseminate it, emails, push it into other SQL Server databases, push it to XML files to be consumed by other systems. So the amount of custom code is massive, which means maintenance is pretty massive. I mean, you just can't upgrade it. You know, all these little pieces are completely custom. So with that, the idea was, well, how do we make the system better without just rewriting all the code in modern technology? I mean, that's going to mean they're in the same exact boat in 20 years if we just rewrite it in today's technology. So,
Yeah.
so we were thinking, well, how do we come up with a low code or even a no code would have been wonderful, but at least a low code solution where we don't write as much code, and we still get the data and we make this data available to everyone who needs it. So, you know, so when we started down this road, we're like, well, what systems are we going to use? How can we do this with the requirement being we're not allowed to change any of those other data sources on the outside? We can't ask for data in a different format from ERP. We cannot ask the PLC guys and gals to change anything about the programming. We're not allowed to change any other system. We simply need to replace this middle system without any changes to the other system. So how do we do that? Well, you know, first you want to get into the unified namespace. You know, that's how you want to be able to make the data available to everyone. But how do you get data from a screen scrape, you know, from an HTML page and get it to unified namespace? How do you get data from an XML file into the unified namespace, from a SQL Server database, from PLCs, all these different data sources? How are you going to get them into the unified namespace? You know, that's where they want to be. This diagram that you see is beautiful. Just connect them all. But what if your ERP can't talk to the unified namespace? It couldn't. What if the MES can't talk to the unified namespace? You know, so that's what we're facing. All these systems cannot just go straight to MQTT, you know, straight to your data broker. So, I mean, that's where HighByte comes in, honestly. And it was HighByte was critical to the success of the solution because it allowed us, with all of its different connectors, to go to SQL Server and get the data, go to Kepware, which is where we were getting all of where all the PLCs are connected, and with a little bit of code, very small bits of code, we were able to create connectors to allow HighByte to pull data from access databases, from screen scrape, from XML files, and now all of those different data sources can come into HighByte. HighByte can model it, can join the pieces together that need to be joined, build these beautiful models, and then push it into your unified namespace, you know, into your HiveMQ, so that everyone in the company and all the other systems can have access to the data. They'll know when it changes, and they'll have good modeled data, not just raw, you know, data straight from the PLCs.
So why don't we? Oh, go ahead, Dave.
I was just going to ask, so are you able to share what some of those models are? I realize you can't share the client, but at least give us an idea, or me an idea, of what type of models got built. I mean, you mentioned 30 plus systems to do something. I mean, you now have, you know, what does that look like?
If you don't mind, let's explain like what the company does and kind of how the process works, you know, kind of this diagram. And then I was going to do exactly that, some of those models, because, you know, we've actually got one illustrated here too.
Oh,
we can
perfect.
dig into. So, Tim, help me through this process. I know some of this too, but we've got a plant here which processes some aggregate product, and then there are conveyors. This is my simpleton way I could create an illustration of a conveyor in PowerPoint here, and the product on the conveyors then goes into bins. And those bins have levels, and then the products are loaded into trucks and shipped out to customers. And we've got PLCs controlling the conveyors, PLCs doing some monitoring of the bins, have some technology, if you will, on the QA analyzer, and then you've got all these other data sources. So kind of walk through how this solution works, kind of given what you've said, and then, yeah, let's get into the models with HighByte, which is a really key piece of this whole thing too.
Yeah, so I'll just start with the flow, like you said. So they manufacture the product, it goes onto conveyors. Surprisingly, the conveyors, Kevin, are not quite as simple as what we have drawn here. It's a series of different conveyors, and then those conveyors. There's also a series of different bins, and so there are gates that open and close, and that controls which bins the product actually goes into. So it's not just one conveyor going to bin one and another going to bin two. It goes through this entirely orchestrated system of conveyors and gates to end up in a bin. So why is that important? It doesn't matter. It ends up in the bin. What's important is when the product gets into the bin, so it's going down the conveyor. The analyzer analyzes it and pulls out a bunch of measurements, moisture being one of them. So, the product has a moisture reading of 1%. So it has 1% of moisture in the product. And then that goes into a bin. Well, we actually want to know, well, which bin did that go into? So PLCs tell us which conveyors were running, which gates were open. So now we can tell which bin this product went into. And through the analyzer data, we know, well, what was the quality of product that went into that bin. So we can see 7,000 tons of product went into bin 3, and its moisture content was 1%. 5,000 tons of product went into bin 2, and its moisture content was 4%. So, excuse me. So we're capturing all this PLC data, the scales, the PLCs. They're telling us the product that's being moved. The analyzers telling us the quality. HighByte is just constantly, being fed that information. Oh, we have this many tons of product moving across the conveyor. Analyzer of this, it's going into bin X. So it's pushing that into HiveMQ. That's also pushing into the historian. So we're recording all this data. We're for into historian. We are publishing it for HiveMQ, and then HighByte also. Let me take a step back. So HighByte is pushing it in historian, but then we also have SQL processes that use that data, the historian data, to aggregate the data in those bins. So we can see that 5,000 tons of product went in first, then at moisture level 1, then another 5,000 went into the bin at moisture content 3%. And so we can build these layers. We can actually we can derive, well, what is the quality of product that's in each of the layers of the bins. And so the models were that. So that's a lot. So one of the models would be the bin, the layers of product in the bin, and it would say that layer 1 is 5,000 tons. Its moisture content was 1%, and then there's various other readings as well. We'll just use moisture, but so we can see where that came from the plant as well. Apologies, getting getting crazy here.
It's all good.
Okay, so we can, so the one of the models is the layer, and that's going into HighByte so that we can see that bin 3 has 4 layers of product, and we can see the moisture content of each of those layers of product, and that means when we're loading those into the trucks, we can the control operator can.
Yeah.
So one model would be the model of the bin itself. That would be that its level is 98% full. It has 5 layers of product. Layer 5 has a moisture content of X, layer 4 moisture content of Y, and the different tonnage that makes up those layers broken up into roughly 5,000 ton layers. So that's one model of models. A layer is a model, and then the bin itself is even a bigger model. And that's derived. Like there's no PLC that tells you the quality of product that's in the bin. You had to track that as it was being analyzed and being dumped into the bin, and recorded in your historian, so that you can then go back and compute, well, these 5,000 ton segments, average out to this quality of product and so forth. So that's one model, or I guess that's a couple of models. We actually modeled each belt itself. So a conveyor belt has a few different things about it. One, is it running? That's simple enough. But they also, a lot of these belts have built-in scales with them. And so those scales will say, well, how much tonnage of product is being moved across the conveyor belt right now? And also RPMs, how fast is the belt moving? So we actually model that belt itself, and we push that into the data broker, so that if you look at belt Alpha Bravo, then you can see it is running, its RPMs are 3,600, and it's currently moving, 200 tons of product right now. So, and then so every time you look up a belt, you'll have that data available. Some of the belts don't have scales, so you would only get whether it's running and maybe it's RPMs. But yeah, so we modeled the belts, we modeled the bends.
You were telling me about some modeling with trucks as well and data from the ERP.
Yeah.
That was really interesting as well. And again, all of this modeling is done on HighByte, right?
Yes, it is. It is. So when the transport, the truck comes into the yard, it's actually scanned by another system, so they know what truck is coming in, and then so we receive that. We can receive that truck Alpha Bravo Charlie just pulled in, and then HighByte will combine that with ERP data to say that truck Alpha Bravo Charlie is from customer XYZ. So we know that this truck is here to pick up product for a specific customer. And that customer requires product to have a moisture level of 2% or less. So that's important because the operator who's going to load that truck needs to know what quality of product to put into the truck. Well, how does he know what quality he's going to put in? He looks at the bins and he looks at the quality that we've computed in each of the layers to know, oh man, everything at the bottom of bin 3 is like 4% moisture. We definitely can't use that bin. Looks at bin 1 and it's less than 1%. That's amazing quality product. So, but bin 2 is, it's the Goldilocks. It's right there. It's 1.5% moisture. That's the most we can use, but still meet the customer's threshold to have less than 2% moisture in their product. So that's combining of PLCs with aggregated data with customer ERP data to know how to make a decision on the fly of where to get product from to physically load into the truck. Or I say physically, a machine that opens the bin, moves it over, analyzes it again, then drops it into the truck, to be transported off.
So does that help answer your question, Dave? You were asking about the.
Yeah, it sure does. No, I just wanted to know. I mean, it builds models. What kind of models are you building? Because that's really, from what I understand, that's the power of the tool.
Right.
Yeah.
Right. So, Tim, some of the things that you were talking about at the beginning, no code, low code, et cetera. I remember you getting really excited about being able to use HighByte because it saved you a lot of time. Can you speak to that a little bit?
Yeah. First of all, I love to write code, so it's surprising that I would seek a solution that that requires as little code as possible. But when you take a step back, the right decision is to only write custom code if you have to. If someone has already written the code, then you should use that. And so with HighByte, that product already exists to replace 30 plus applications that did things that we already know how to do. Read access databases, query SQL databases, read XML files, and then combine that data just to be pushed into another data source. There's no reason to rewrite all of that code again and again and again when something like HighByte can just query the data. It can let you model it right there through the user interface, and then push it out wherever you want it to go. In our case, to HiveMQ, but it could be going anywhere, honestly. So instead of rewriting those 30 applications that do things that have been done a million times before, HighByte just took care of all of it for us.
So you took 30 applications, replaced them with HighByte, and presented all that data in context to the unified namespace that could be consumed by any system. Is that, in summary, what you did?
Yeah, pretty much.
I think that was like 10 words or less. That was pretty
Yeah, no, maybe we should have, maybe the video could have been over at the 30-second mark.
Right? Yeah. No, well, I mean, it's good to see how it gets used, because
Yeah.
we can talk theoretically of, oh, you can use it for this, but here's a great real world example of a client that had 30 applications and
Yeah.
all these just oddball things in custom code, and now we're able to solve it, using a simple tool set. So that is amazing.
Yeah, one of the other things that has come up in our conversations about this project, Tim, you know it as well as I, you know it better than I, is that some of the people in the company have actually been starting to realize, oh wow, you've got all this data. Can we have some? We want some too, kind of thing. And it's not a huge deal to pull that data out at this point. I mean, would that be fair to say?
Yeah, that's exactly right. So, we were we were doing a demonstration of the solution we had, and we talked about how the open architectures we used, that can communicate. Any tool that understands MQTT can know when data has changed and is available. And on the call, someone was like, "Oh my goodness, I would love to be able to get these conveyor belt data. I want to know." I want to have access to all the conveyor belt data, because I want to build these charts of, well, how much time were the belts running versus not running. All these things that the original solution didn't need to do, but is now available for anyone to pull this data, or to subscribe to the data, aggregate it how they see fit, and make their own decisions based on that. So yeah, for sure. So we don't have to write any code. The data is available. I think in his case, he was going to use Tableau to connect, but really anything that speaks these open architecture protocols, SQL or MQTT.
Mhm. Interesting. So, what kind of challenges did you have when you were looking at this solution, having written lots of software in the past, and done a lot of architecture work as a senior developer, consultant, architect? What kind of challenges did you have in looking at this as a new way of thinking, a new way of working, and especially wrapping your head around HighByte and how it could operate? What was that like?
Yeah, so the first challenge was, I knew the unified namespace was the way to go. The challenge was, I'm not allowed to change any other system. The ERP that produces an XML file that gets FTP'd over to the server, I can't change that. And how are you going to? That doesn't talk to MQTT. My challenge was, how am I going to get it in there? I'm going to rewrite the same code that was written 20 years ago. And I just knew that was not the right way to go. I mean, it just did not feel like rewriting all that code was the right way to go. So, then it's, well, how are we going to get all these different data sources in? And HighByte, it just does it. We had to write some code. It doesn't directly interface Microsoft Access, so a small, we put together a very small .NET Core REST endpoint that would let you pass in a path to an access database and a SQL query, and it would run that query and make the data available to HighByte. Similar for the XML file, just a REST endpoint that HighByte connects to. It gives you the XML file. It specifies the XML file that it wants, and that endpoint just reads in the file and provides it to HighByte in JSON format, and then HighByte takes the rest. So there were a few places where we did have to write code, but the goal was write as little code as possible, and then let HighByte handle the rest. So it was always, how do we get it into code that's already been written to process data? And so for each different data source, we approached it that with the screen scrape. HighByte doesn't screen scrape. It won't go to a URL and parse out the HTML and get the data you want. But you can write very minimal code, expose it, through a REST endpoint, and just let HighByte call that endpoint whenever it needs the data, and then that little endpoint will go and scrape the HTML and return the data. And then, from that one little bit of code on, everything else is just open architecture. Once it's in HighByte, it's JSON. It can go anywhere. It goes into unified namespace, historian, all that stuff. From that point forward, it's available for everyone.
So then that kind of leads me to kind of starting to summarize, because I want to respect everybody's time here. And Dave, I'm going to ask for your thoughts as well. This again, that 10-word or less, if I could repeat it, I would, but that 10-word or less description Dave, you gave was really good. And then what this all leads to me, is flexible and scalable. To let's say the nth degree. I mean, up on the top right of the screen here, that discrete connections mess is not scalable at all. But we have replaced the existing or the previous system, like right at the center where there was all this spaghetti connections, with a single system with a very clean architecture, using, I'll move this around here a little bit, using this hub idea with the MQTT data broker, and using the unified namespace, with the layers of the solution here, and made this incredibly flexible, such that it doesn't take that much work for somebody to start pulling off data, and using it however they want. So incredibly scalable, incredibly flexible, and we will likely be building on top of this solution, and we use this solution for a lot of companies now. So Dave, some highlights, thoughts?
Yeah, I mean, so other than, how you utilized the one tool to replace a whole bunch of others, the thing that really stuck out at me was, now that we have all this data available, there are more people that are coming to you and wanting more data. And that's the cool thing, because now that they know that it's there, that sort of creates what's that next step of what are we going to do now? Because as we've learned, that what you do today is a function of what you know today, and what you do tomorrow is a function of what you know tomorrow. Well, now all of a sudden that there's all this data that's available, now those are the types of things we can start doing, which ultimately is going to unlock that value from the plant floor. So very cool stuff, Tim.
Yeah, and that's an interesting point you bring up. The thing that we hear about and talk about a lot is that companies kind of question, well, should we get into this kind of effort? Should we start pulling this data? And there can definitely be some direct benefits and some ROI that you can get pretty directly from these kind of solutions, this kind of architecture. And this architecture, it's not expensive to set up. It's not massive costs. But companies struggle to figure out whether spending the kind of money for doing all the monitoring and whatnot makes sense. And a lot of the value can happen now, but just as you're inferring, a lot more of the value comes down the road, because now we have this platform, we have this structure, and we can just build on it, and keep it going, and it'll still stand strong, and provide an enormous amount of value in the future, far, far beyond what it's providing directly right now. So it's a lot of that indirect or unknown value that actually comes out of these projects. Would that be a fair way to put it, Dave?
Absolutely. Yeah, there's no way you could have ever written a statement of work around what we know now.
No, not at all. Good. All right, Dave, Tim, thank you very much. Tim, awesome work on this project. We're all really happy with it, and I know the client is too. So thanks for your time on this call.
Awesome. Thank you, guys.
Sure.
See you guys.